Hello and welcome to the course of Material Science and Manufacturing Processes. So, in the previous lecture, that is lecture 1, we have introduced with you about the classification of the material science. Now, in this course, this is lecture 2, we will study about the we will study about the ferrous metal and their alloys, about the ferrous metal and their alloys. So, in the syllabus, we have cast iron and plain carbon steel. Now we will see first the lecture objective. The lecture objectives. The lecture objectives are to understand the term ferrous material. So first we will understand what is ferrous material. After that we will study and identify about the general classification of the ferrous material. What are the general classification? How the ferrous material is classified. After that, we will analyze the types, composition, and application of the cast iron. And finally, we will introspect about the plain carbon steel, that is, and their types, composition, and application. So now let's start the lecture. So ferrous metal and alloy. What is ferrous metal? Ferrous means if the base material, it is simply the metal, a metal or alloy that contains iron, that is element ferrous as base material or as base metal. Means maximum percentage should be of iron. So there are especially important they are especially important for engineering construction material and has wide application so as has wide application, so we have to study about the ferrous metals and alloys. So firstly, what is ferrous metal? Ferrous metal means it should contain iron, that is Fe, that is ferrous Fe. So it should contain Fe. So iron containing why they has wide application, because iron containing compound exist in abundant quantities. Abundant quantities means in huge quantities. And another thing is that point B, that is metallic iron and steel alloy may be produced using relatively economical extraction, refining, alloying and fabrication technique. That means using iron. That means using iron is very easy to our day-to-day life and to our day-to-day construction and engineering materials. So, and the third point is ferrous alloy are extremely versatile. They can be used in many places, as they can be because they can be tailored to have wide range of mechanical and physical properties. In the last lecture, we have discussed about what are the mechanical and what are the physical properties. So now steel can have a huge range of wide range of mechanical and physical properties. So due to these three mainly due to these three reasons, steels can be used as a important ferrous metal and its alloy can be used as an important engineering material. So there is one disadvantage with ferrous metals, that is the principal disadvantage, that is they may be susceptible to corrosion. That means they can be corrode very easily. Means in atmosphere, if you keep a iron rod, if you keep a ferrous metal, then it is tends to be corrode very easily. It tends to be corrode very easily. Corrode means, or corrosion means, de- it's a de- decomposition process. It's a decomposition process. By corrosion, the surface of the material is deteriorated and the strength of the material is decreased. So corrosion is is not a corrosion is not a expected phenomena. It is unexpected phenomena. So it's a disadvantage to for the ferrous alloy because they are prone to corrosion. So now we will see the classification of the ferrous metals and alloy. So ferrous materials and alloy can be broadly classified according to their composition only. So according to their composition, most precisely according to their percentage of the carbon content, according to their percentage of the carbon content. Why this classification is taken? Because according to the carbon content, the properties of the ferrous material, the properties of the ferrous material depends on the carbon content. So composition means the carbon content. carbon content. So see, first the cast iron which have percentage weight more than 2.24 percentage weight of the carbon. So if a iron has more than 2.214% of weight of carbon, then it is called cast iron. We will discuss about this cast iron in detail in the later section in this lecture. Now there is steel, and now steel can be divided into plain carbon steel where carbon percentage varies from 0.008% of weight to 2.14% of weight, and there is alloy steel. Alloy steel contains uh, other alloying element along with the iron and carbon. So in plain carbon steel can be classified into three sub class, that is low carbon steel where the carbon percent is varies from 0.008% weight to 0.3 percentage of weight, and medium carbon steel that is greater than 0.3% of weight to 0.6% of weight of the carbon, and high carbon steel that is having 0.6% of the weight to the 2% of the weight of the carbon. So now alloy steel may be classified into two sections, that is low alloy steel and high alloy steel. In low alloy steel, alloying elements should be less than 10%, and in uh, high alloy steel alloying element can be present at equal to or more than 10%. So now first we will see about the cast iron, their types and composition and application. So cast irons are the class of ferrous alloy with carbon contents above 2.14 percentage in weight. So wherever carbon percentage is 2.14% or more, then that is called cast iron. However, most cast iron contains between 3 to 4.5% of weight of the carbon, in addition to other alloying elements. So in cast iron there is also some alloying element, but the here is major thing here is iron and carbon. So for most of the cast iron, this carbon exists. So in cast iron, what we got irons and carbons. So in iron and in between iron and carbon, there carbon exists as graphite form. So carbon exists in the graphite from and both the microstructure and the mechanical behavior. So both the microstructure and the mechanical behavior depends upon the composition. That means depends upon the carbon amount of carbon and heat treatment. Why heat treatment is important? Because as the carbon exists as graphite, which is flammable, which is prone to which can absorb the heat. So that's why it is these compositions, this microstructure and mechanical behavior depends on the composition and heat treatment. About heat treatment, we will see heat treatment in the later section of our course. Now, the most common type of the cast irons are grey cast iron, nodular cast iron, white cast iron, and white cast iron, malleable cast iron, and compacted graphite cast iron. Now, see, grey cast iron. In grey cast iron, the carbon percentage will vary between 2.5 2.5 to 4% of weight, and there is another alloying element which is called silicon. So iron, carbon, and silicon, they together they make an alloy that is known as grey cast iron. In grey cast iron, the composition will be grey cast iron composition will be 2.5 to 4% of the for 2.5 to 4% of carbon, 1 to 3% of the silicon respectively. So here graphite exists. Here the graphite means carbon exists in the form of graphite. In this grey cast iron, the structure of the graphite is in the form of flakes. Flakes means you have seen in the cornflakes that many people take as breakfast, that cornflakes structure of the cornflakes you have seen. So that complex like structure can be seen as in the microstructure of the grey cast iron, where the graphite is in that flake forms. So for most of the grey cast iron, because of this graphite flakes, the fractured surface, mean broken surface, takes an gray appearance. So why grey cast iron is called grey cast iron? As it has because it has graphite in the form of flakes. Now these flakes, when cut or broken, these flakes takes an appearance of gray color. Takes an appearance of color gray, and that's why the name is grey cast iron. So there are typical applications. So the applications are miscellaneous soft iron casting where strength is not necessary, small cylindrical blocks, small cylindrical blocks, cylinder head, piston, clutch plate, transmission gear, and diesel engine casting liners and cylinders. These are the typical application. These are the typical application of grey cast iron. These are the typical application of grey cast iron. Now we will see about nodular or ductile cast iron. So adding some amount of, so in the grey cast iron, if we add some amount of magnesium or cerium, so before casting, then a new alloy is produced that is named as nodular or ductile cast iron. So why nodular? Here graphite Here graphite transformed to nodules or sphere-like particles, so, instead of flakes. So due to addition of magnesium or cerium, the graphite takes the shape of spear-like particle or nodules. So now instead of flakes in the microstructure, exists? Instead of flakes, there exists nodular shape or sphere-like shape. So this nodular or sphere-like shapes do what? They increases the ductility. Ductility means it's a property by virtue of which a metal can can transform into wire. That means that they can resist the tensile force. So that is ductility. So tensile force or tensile pull. So that is ductility. So by adding magnesium or cerium in grey cast iron, what happened? A new alloy with higher ductility is can be made, and that type of cast iron is known as ductile or nodular cast iron. Now, what are the typical application of nodular or ductile cast iron? The valves, pump bodies, crankshaft, gears, and other automotive parts can be made using nodular cast iron. Pressure containing parts like valve and pump bodies. Why pressure containing parts? That means it is it can it can resist some kind of, it can resist axial pull, it can resist axial pull, so that's why we can as the ductility is more, so pressure containing parts like valve pump bodies can be made. High strength gears and machine components can be made. High strength gear high strength gear and machine component can be made. Pinion rollers and sliders that also can be made using nodular or ductile cast iron. Now we are coming to the white cast iron. In white cast iron, the low silicon cast iron for low silicon cast iron containing less than 1% of wet silicon, of the wet silicon, and rapid cooling rate, most of the carbon exists at cementite instead of graphite. So what happened when there is small amount of the silicon? So till now what we have studied two types of the cast iron. First one is grey cast iron, which have iron carbon along with some amount of silicon. Now if we add some magnesium or sodium to the cast iron, to the grey cast iron, what we got? We got nodular or ductile cast iron. Now, if the amount of the silicon is very less, that means that is less than 1% of the silicon or low silicon cast iron. In low silicon cast iron, due to high cooling rate, what happened? The graphite, the carbon exists in the form of cementite in place of graphite. So here graphite is not present. Carbon form cementite. So this cementite, as the amount of the silicon increase, this cementite decomposes into graphite. So that's another part that we will discuss later on. But the thing is that the carbon exists in the form of cementite. So when a fractured surface or broken surface has been seen, it appears like it appears white in color. Thus, it is termed as white cast iron. So why white cast iron is called white cast iron? Because it contains cementite instead of graphite. The cementite, uh, when the surface is broken, cementite looks like white. Cementite appears as white surface. So now next, what are the application? This white cast iron has very limited application. Mainly it is necessary for very hard and wear resistive surface without high degree of ductility. For example, roller and rolling mills. Now, it is main use of the white cast iron to intermediately used as intermediately in the production of yet another cast iron, that is malleable iron. So to make another type of cast iron, that is malleable iron, the intermediate production is white cast iron. Inter, it is a intermediate product. So now malleable cast iron. Heating the white cast iron, if we heat the white cast iron or white iron at temperature between 800 to 900 degrees Celsius for prolonged period of time in a natural atmosphere, that cause decomposition of cementite and forming graphite, which forms cluster, which exist in the form of cluster in the microstructure. So that increases relatively, that that induced this process, this heating of white iron induced relatively high strength and ductility and appreciable ductility and malleability. Now, the the applications of the malleable cast irons are connecting rod, transmission gear, differential case for automotive industry, flanges, pipe fitting, valve parts for railroad, marine and other heavy duty services. So these are the importance for malleable cast iron. Now another type of the cast iron has been emerging in trend, that is compacted graphite cast iron or CGI, compacted graphite iron. So relatively recent, this carbon exists as graphite. Here carbon exists as graphite, and whose formation is promoted by the presence of silicon. Silicon contents here ranges between 1.7 to 3% of the weight, and carbon concentration is 3.1 to 4 percentage of the weight. Graphite in CGI or compacted graphite alloy has worm like shape. Okay, it has worm like shape. Now it can be used, it can be superior to other cast iron as it includes higher thermal conductivity, better resistance to the thermal shock, and lower oxidation at elevated temperature. These are the properties for which the compacted graphite is superior from the other cast iron parts. Now, compacted graphite iron can be used for making diesel engine blocks, exhaust manifold, gearbox housing, brake discs, and high speed trains, brake discs for high speed trains and flywheels. Now we will come to the steel part. In steel there is alloy steel and plain carbon steel. So what is steel? First, steels are iron and carbon alloy that may contain appreciable concentration of other alloying elements. So mechanical property are, are sensitive to the content of the carbon, which is normally less than 1% of the weight. So this is for steel. Now plain carbon steel contains only residual concentration of the impurities other than carbon. That means in plain carbon steel the maximum content concentration is of iron, and after that the concentration is of carbon, and the residual part, only the residual part is filled by the other alloying elements such as little manganese. So, and in case of alloy steel, more of the alloying element is intentionally added to the specific added in specific concentration to have a specific operations or have a specific function. So the most common type of the carbon steels are low carbon steel, medium carbon steel and high carbon steel. Low carbon steel, medium carbon steel and high carbon steel. Now see low carbon steel. For low carbon steel, they generally contains low carbon steel generally contains about 0.25 weight percentage of carbon and a little manganese. So what is the composition? Composition is iron and 0.25 percentage of the weight carbon and a small amount of manganese. This is unresponsive to heat treatment. That means this is unresponsive to heat treatment and heat treatment that intended to form martensite. Strengthening can be accomplished using the cold work process. So what these terms heat treatment and martensite, these terms will be discussed in the later section. In the syllabus we have in heat treatment, so we will discuss it in detail there as a whole chapter. So now, what are the typical application of the low carbon steel? The typical application of the low carbon steels are automobile body component, structural shapes such as I-beam, channel and angle iron, sheets that are used in pipeline, building, bridges and tin cans. So this is for liquid low carbon steel. Now for medium carbon steel, carbon concentration is between 0.25 to 0.6 percentage of weight of the carbon, and these alloys can be heat treated. These medium carbon steel can be heat treated by austenizing, quenching and then tempering to improve the mechanical properties. Now several alloying elements can be added to improve the mechanical properties and the microstructure of the medium carbon steel alloy. The application includes railway wheels and tracks. The application includes gears, camshaft and other machine parts, high strength structural component and calling components calling for a combination of high strength, wear resistant and toughness. These are the typical application where the medium carbon steel is used. Now for high carbon steel, it has normally having the carbon contents between 0.6 to 1.4 percentage of the weight. It is hardest, strongest, and yet least ductile between the carbon steel. It is always used in hardened and tempered condition. It is always used in a hardened and tempered condition. As such, there are especially wear resistant and capable of holding a sharp cutting edge. These steels are utilized as cutting tools and dies for forming and shaping material, as well as knives, razors, hacksaw blades, springs, and high strength wire. Thank you. So this is for today. So we will discuss about the alloy steel in the next lecture, and the effect of alloying elements. That also we will discuss in the next lecture. Hope you enjoy the lecture. If you have any problem or any doubt, that feel free to contact with me. So thank you. That's it for today. We will discuss about the problem in the live classes. Okay, if you have any doubt, we will discuss it in the live class. Thank you.